Okay, so f of x equals cosine of 2x plus pi over 6. And we have p of x is a third degree polynomial centered at 0. You want to use the Lagrange error bound to show that f of 1/3 minus p of 1/3, that absolute value, is less than 1 over 100. So in other words, we want to show that my maximum error is going to be less than 1 over 100. Okay, so I am going to just figure out, okay, we're starting with cosine of 2x plus pi over 6. So I want, since I'm using a third degree Taylor polynomial, I'm going to go to the fourth derivative. So f prime of x, so that's going to be negative sine times 2x plus pi over 6 times 2 for chain rule. So second derivative, so that's going to be negative 4 cosine of 2x plus pi over 6. My third derivative is going to be positive 16 sine 2x plus pi over 6. And then my fourth derivative is going to be 16 cosine of 2x plus pi over 6. Okay, now this, again, this is my remainder, what I have here. So let's figure out what is the maximum error for that. Now notice I'm not actually finding the Taylor polynomial. I don't need to. It just says use that to figure out how far it's off. So r sub 3 of x, we have the absolute value, so we're going to have the fourth derivative of z, and it's centered at 0, so it's just going to be x to the fourth over 4 factorial. Now, what is my x in this case? It's 1/3, so x is equal to 1/3. And since I'm working with cosine, right? So I have 16 cosine of 2z plus pi over 6, 1/3 to the fourth power, all over 4 factorial. When we work with sine and cosine, we always just consider what's the largest so don't worry about figuring out z, just look at the sine and cosine, right? Cosine, what is the maximum that cosine could be? Is 1. So we make that whole part that I highlighted equal to 1. So I'm making this. The largest this could possibly be is 1. So I have 16 times 1/3 to the fourth over 4 factorial. That's already positive. And let's see, when I calculate that, I get about 0.00034294.